Hi, my name is Bogdan Marin. You might remember me from such transformer videos as the kick test and parallel transformers. Now I'm here to bring you effect of voltage on contactor coils with my cameraman, JJ. All right, we're going to start on lab 14-1, effect of voltage on a contactor coil. So I'm here to bring even more than what's in the lab. I have a contactor here without a shading coil and one with a shading coil. We will be doing our lab on the one with the shading coil, but after I will show you the effects, or throughout the lab I'll show you the effects on one without a shading coil. Okay, so the purpose. Current flowing through the coil of magnetic contactor creates magnetic flux which causes the armature to be attracted to the stator of the contactor. The strength of the magnetic field is proportional to the magnitude of the current flowing through the coil. The air gap between the armature and the stator of the contactor increases the reluctance of the magnetic circuit and lowers the flux density. Because the air gap is eliminated, once the armature is pulled in, it requires more current to pull the armature in than it does to hold it in. All right. The inductance of the coil is dependent upon the reluctance of the magnetic circuit. Therefore, once the coil is pulled in and the air gap is reduced, reluctance decreases. The induction of the coil increases. The increased inductance of the coil after the armature is pulled in decreases, holding the current through the coil. Wow, that's a lot of info there, okay? Essentially what they're saying is as you apply current on the coil, you create a magnetic field, creating a magnet, making contact between the 2 points in the contactor, sucking it in, and then it's saying that it takes more to get it to seal and less to hold it there. That's what they're saying, okay? There is a spring there that holds it away from each other and pushes it back apart. And you have to count for that. Okay, so let's start in the beginning here. Okay, so I have a 0 to 208 actually supply here, but anyways, 0 to 140 is what they say here. I have my ammeter, 10 amp scale, because I'm going to have a couple of readings potentially higher than 1 amp, maybe. And I have my shading coil here. So I have it wired up. Coil is in series with my ammeter, which is in series with my source. I just have one big series circuit. It's quite tough to wire, but I did it, guys. Don't worry. All right. Now let's turn this on. It's on right now. And as I turn up my rheostat here, we will see my voltmeter rise. Okay, so starting with 0 volts, slowly increase the supply until the coil of the magnetic starter pulls into the armature. Record the values below. It may require doing this step several times since the pull-in current is the current just before the armature pulls in. All right, so place your bets on what value it'll stop at. Okay, we're at 45 volts, nothing. I'm right at about 75 volts and I can start hearing a little bit of sound on the contactor. However, nothing's pulled in yet. 78, 81, 82. It actually pulled in at about 120. It took full voltage to pull this guy in. Okay. It took about full voltage to pull this guy in. Now the pull-in current here was approximately 0.19 amps, so 120 milliamps was the pull-in current. Okay, increasing the supply to the rated voltage of the coil and record the values below. Okay, so this is rated value. So this coil right here did not get pulled in at anything less. This is a very, very old coil. We got some newer ones in the lab over there for the next one. We'll try this again for the next ones. My guess is those coil values will be lower. Okay. Now with increasing the supply, so we got our values here. So pretty much rated supply, current, and what it took to pull it in. These values are virtually identical. It's about 126 and 118. Now with rated voltage applied to the coil, slowly decrease the supply voltage until the armature drops out. Okay. So you guys, you're hearing this chattering sound, okay? And it just dropped out right now at 90 volts. It dropped out. So it dropped out at 90 volts and approximately 0.86 amps, so 860 milliamps it dropped out at. I hate that sound, so I'm going to close it back up here. Okay. With rated voltage applied, prevent the armature from pulling in by using a piece of wood or plastic pen. Record the coil condition. Whoa, I didn't expect to have to do this. Okay, so prevent it from pulling in. So I'm gonna I'm going to try this here. Okay, I'm going to get about 1.3 amps. I got about 1.3 amps now. I was preventing it from pulling in. Okay? You don't want to do that for too long. You're potentially going to damage it. Okay. Now, de-energize my circuit. All right. Switch the supply and meters to DC. Connect the magnetic starter in series with the 2.5 ammeter DC ammeter and 120 volt DC supply. So this will work for DC. I just have to press that button. Now I'm at DC, okay, and I'm gonna put my, this is off here, I'm gonna go to 0 to 120 DC right here, and I'm gonna change it to my DC, which is right here. So it's 7 and neutral right here. Okay, so let's see what values we get when I connect this to DC. Okay. Gotta turn it on first. Oh, look at that. Oh, I think I'm gonna go fast here. Let's see. Wasn't expecting it to click in at such a low voltage. So it clicked in at about 60 volts. It clicked in. Okay? It pulled in at about 60 volts, and the current was approximately 1.19 amps. All right. Slowly decrease the supply voltage and see where it pops out. Okay, so I have this out here, and I am going to slowly decrease this and see where it kicks out. It kicked out pretty low here. Let's try this again. At about 4 volts it kicked out, and approximately 0.05 milliamps, sorry, 0.05 amps or 50 milliamps. Okay, clean up your work area and return all your equipment in place. Okay, so before we do all that, let's answer, or sorry, after we de-energize everything, let's answer some questions. What percentage of AC rated voltage did the armature pull in at? This was actually close to 100% using this old armature. Usually most contactors pull in at about 70%, usually. What percentage of rated AC voltage did the armature drop out at? So this dropped out from our values there. We can see our values, but on average it's about 50% is when it usually drops out. When the armature is held open, why is the coil current greater than normal? Well, the open causes a higher magnetic reluctance and a lower counter EMF. How is the low voltage protection provided on a magnetic starter? Well, low voltage protection, remember, when power goes out, it will not automatically restart, so you have to push that button back in, requiring 3-wire control, meaning you have to wire in the seal-in contact. In the same magnitude, DC and AC voltage were applied to a coil, which circuit will draw more current from the source, and why? DC has no reactance, only resistance. Okay? Is the reluctance of the magnetic circuit higher when the armature is pulled in or when the armature has dropped out? When it is dropped out. Is the inductance of the coil higher when the armature is pulled in or when the armature is dropped out? It'll be when the armature is pulled in. All right. Well, thank you for tuning into this lab, and I will see you guys next time. Bye.